Yeah, it's 3 o'clock, so I guess I have to start with this talk about how to basically create 78 Google service bindings in 5 seconds. Obviously, this headline tries to be catchy and tries to grab people's attention, because what I'm talking about obviously is how to use a code generator and structured data to produce lots of other code that will then be compiled to resemble something like bindings to all Google services that there are. This is a project I'm currently busy with, and you can find it on GitHub. It's right here. It's github/Google APIs for Rust-RS. So Rust is this new fancy system programming language that will see the light of this world officially on the 15th of May this year. It's not far away. Right now it's beta, and because it was asked already, you don't need to understand Rust to understand the talk, because what I will be busy with is telling you why I'm motivated to do this, why would somebody actually want that, and how this can be achieved using standard tools that are, actually commonplace and quite well made. Also, this is kind of an ad hoc talk. I didn't prepare this particularly well. All I will need is a few, Chrome and Sublime Text and a shell to show you around the project. If you have any questions in the middle of anything, just interrupt me, just raise your hand, and I shall answer them as good as possible. It's more like it should be interactive, right? So just go ahead and get into a dialogue. Any questions so far? All right, that's good. First of all, why would you need bindings to all the Google services? What are Google services anyway? It's the big ones that you probably know already. Anybody knows them: YouTube, Maps, Drive, and many more. Analytics, DFA reporting, some weird things that some weird services that I didn't know before, but they're part of the 78 ones. And the only one I'm interested there, we talk a bit about motivation, is YouTube, right? Because the YouTube uploading that you have built into the browser is quite nice, actually, but it doesn't support resume properly. It kind of can do that, but if you're bored for some reason, if you close the tab, if you close the browser, if you have to update your browser, if you have to update your system to get to the latest state of security that there is, you might have to abort an upload, and you can't get the result back. In my case, I've just got one Mbit upstream, which means if I have to spend hours to upload a video, I'm really not willing to redo that just because I have to restart the browser or something, or have an accident with my browser tab. So what I want is really just a tool on the command line that I can use to upload things that should automatically queue my requests and do the right thing even when I reboot. Because the technology is there. All the major services of Google that support uploads, they do support resumable uploads as well. And this means that the server will basically remember the state of the upload operation for an hour or so that you can come back later and keep sending the bytes that you missed so far, which is really cool. But the tooling is not there the way I would like to see it, let's just say. There are tools out there that are supposed to be doing it, like Java tools with graphical user interface, but it's nothing for me. I'm a command line guy. And I'm also a Rust fanboy, so I really wanted to get down and dirty writing some actual Rust code and have some real project to see how it really is to use that language. And yeah. So first I started quite naively. Well, actually I should probably go back to the first analysis of the project. To have a YouTube uploader, what you definitely need to do as one of the first steps here is authorization, right? Before you do anything with any API that uses your account, you need to authorize yourself, which is fair enough. That was expected. And this is done using OAuth 2 with all the Google services that I know of, which seems to be a standard. And sorry that I'm so reluctant here to say this is a standard, because I really have no clue. I just read about it when I had to implement it. And that's kind of the first thing that you want to do before doing any of this. So this project will use the YAP OAuth 2 library, which I also wrote, which really does just one possible authorization flow, which is the device flow. So if you have your PlayStation and you want to upload something to YouTube, then we'll show you some code that you have to enter on some URL, and then you can authenticate the application like that. That's a manually written library here that is basically the basis to do anything. I'm not going to show you what it is because it's really just Rust code and some RPC requests and nothing of interest there unless you're totally interested in Rust, but that's kind of out of the scope. I just want to tell you what's necessary. That was the first thing I did to tackle the project. The second thing was that obviously you need to talk to the YouTube service somehow. You need to do this basically. And then you can start reading the documentation here and see, okay, you have to build these requests and you have to build these headers, and then you have to, oh, there are the data structures that you have to send. Like these data structures can actually be very complex, and then there are these parts that you have, the parts information that you have to tell the server what kind of data it can expect and what kind of data you want to get in return, and it's getting a bit more complex, let's say. But it definitely gets repetitive because it's always kind of the same thing. Sometimes you have upload, sometimes you just want to request data, sometimes you want to update data or insert new information, but it's always kind of the same general idea. You have some data structures that you have to manage. You have, well, I tried that. I tried to implement this manually as well because that was kind of my first idea. I want to have a YouTube uploader quick. I don't want to start generating stuff. Really, I just want to have it. But I think I spent like 2 or 3 hours trying to implement this the way I implemented the OAuth protocol. And I realized it's just too much of monkey work. I can't handle that. And so I had to find a better solution because I'm totally uncreative. And I think a first starting point for finding good solutions is to look how other people do it. And other people obviously are the Google people themselves. And something I usually like to look at is Go code or something related to Go because they have everything. It's quite mature community and mature libraries that they have. And how do they do it? So I found this. That's the Google API Go client. That's basically the thing that I'm doing, but for Go. And that's the structure here. And if you look at YouTube, you have YouTube v3. Let's see what they have here. And that's how it looks like for them. So they have a single Go file that kind of says what it is, YouTube again, and they have a JSON file, right? So first, I just had a look at this thing to learn what it is, and it's telling you that it's nearly 13,000, or well, let's say nearly 12,000 lines of code, including comments, and that's massive. I mean, if the thing is, if you want to manually implement this, like just video upload, then at some point later you will want to maybe modify the description of your video, and then you need another function that you need to implement, and then you will always be missing something unless you have something complete like this, right? That looks pretty good, and it's perfect in a way. It's kind of very uniform. That's what I thought. And there's always this intermixed, where is it? This intermixed JSON stuff for some reason. That I didn't understand initially because I really had no idea that this is in fact generated, even though it's obvious. But I'm really naive sometimes, often. So next thing you do is maybe have a look at this JSON file, and this now it gets interesting because that in fact is a structured document that tells you everything you need to know about the YouTube API. So how do you authenticate? Oh, look, it's OAuth 2 that they support. Here have some scopes and whatnot. Usually have descriptions as well, which can be useful for documentation purposes, just to understand what this really means, and lots and lots and lots of different data structures and different methods that are supported. So if you look at videos insert, for instance, then, scrolling here is a bit difficult. I think I will not use the browser to show this, but as you can see, everything is somehow included here. But you have to use that data, or you have to use that data structure to to generate your code. So what the Google guys or the Go guys do is they have a generator that is written in Go, which looks pretty much like that. And it's, well, it's really just a Go program. And at some point, there is a generate function here or something that actually creates a big string that they output to some file. Here, that's how their code looks like. As you can see, it's really just standard Go code, and they generate strings. That's it. Really straightforward, nothing special about this. And that's how it's done, I thought. So the first thing I thought, hey, I don't really want to write a generator now because, well, I won't have a YouTube uploader. I might even want to just use the Go code here and change it to output Rust code, right? Should be possible. But yeah, I quickly backed up and realized that there might be better ways to generate code nowadays because what they have is a custom template engine here, in a way, you know? So template engine, that was kind of my pointer because template engines are already generating documents of all kinds, like HTML documents, but maybe they can also generate code. So I thought. So I did a little bit of research and tried a few things and ended up finding this little gem, Mako. Mako templates for Python. Okay, maybe it's hate or love, you know, whatever. Python, is it what you want to use? In fact, I have a big Python history, so Python is something I understand very well. It's also something I dislike as a language, but at least I know that I can do everything I want with it without having to fear that there's some technical hurdle that, you know, will take away my time. So that's what I ended up using as a code generator to tackle this. So if you have a code generator, or basically what I'm doing now is I'm adding to my toolchain, because if we recall, we have Rust already in the boat, so I need to kind of compile Rust code. Now I need a tool to generate that Rust code that I want to compile, and probably even more, because, you know, Rust is not just source code. Rust is also a project definition that you might want to provide to use the Rust infrastructure to build your stuff. And that's quite a lot of programs that you want to orchestrate. And we have 78 APIs that are based on these JSON files, which involves dependencies, because if this JSON file changes, then I probably want to rebuild whatever depends on that JSON file. And well, there's a tool for that, obviously. So process orchestration and dependency handling, that's really telling you what you need. It's make. You want make. And I think now I'm going to get into the editor, unless there are any questions so far? Good. And and I really want to be sure that you can follow along and I make my motivations clear. If there's something where I lose you, just let me know, because I would rather try to keep everybody on board here. Let's have a look. Okay, so make is used to orchestrate everything. And the make file that you see here, it has a mere, well, 80-ish lines of make code. This is the only manually written make file that there is in the entire project, which is pretty neat compared to the complexity of the project. Complexity means if I execute make here, then you will see that, well, it shows you what it can do. It's something I find very important. And you see that all the complexity is basically hidden in some sort of sub-makes. Because now, if I want to build APIs, you see there are lots and lots of additional targets here that are available for your pleasure. They're always like aggregate targets that affect everything within a certain category, and there you can always like work with individual APIs, because during development you obviously don't want to build all of the time, but you want to pick a particular API that you're interested in and use that instead. So this is what what this make system looks like, but how is it even generated? You know, where is this information coming from? Well, that's something I find interesting about make. I didn't know it would work that well. One big piece of this manually written make file are these includes, right? Basically, I just say, okay, into my make file, just literally include this other make file that is called like that, and that's just the name of some file that is on disk, which is called like that. You know, that's the make files that it should pull in. But in fact, these make files don't even exist; they are generated. So the first time this thing runs, well, let's see how it works, right? Because I'm in my ready set environment here. What happens if you're new and you want to set this up? What happens? And I'm just showing you what the result of this make infrastructure is so far. Let's open this up and let's start fresh here. I hope this doesn't take too long. I think we have quite a neat, relatively fast internet. Because what I really like in tooling is it should be self-documenting and it should set itself up. And if it can't set itself up, it should tell you how to set it up. But ideally, everything is automated. This doesn't only help you if you get back to the project later, or it doesn't only help others, but it also helps with your continuous integration, you know. Because continuous integration basically wants to do the same thing, just to have a clear slate all the time. So now I have a fresh checkout, and there's not too much going on here. There's a make file, and if I execute make just to see what happens, let's see what happens. So first of all, it couldn't include these files, right? It couldn't find them, which is interesting because I thought make would possibly fail now or do something undefined, but it doesn't. You know, that's just something that was a positive surprise for me because make realizes, okay, I can't find these files, but I actually know how to make them. Here, because these guys, they're also a target. So what make does is it executes the generator, but to execute the generator, it needs the virtual environment, needs Python installation, and basically needs to set up an entire infrastructure before it can do that. And this is what happens here. As you can see, it goes on with setting up a virtual environment where Mako is installed, where all the dependencies are installed. In this case, it's just PyYAML and makedocs as well. And then it calls this just installed Mako generator or Mako template engine to generate the files that it just a moment ago couldn't include. And then it's done. I think the reason this works is that in the first time you include it, you basically don't try to do anything. I never try to do anything with it because these files could basically not be found. But now they are there. The user sees the help and can actually start working with the system. So now I'm in the same state and can ask for help on something that is part of the generator and use it. So yeah, I don't know what I want to use this for, but maybe I find an application for this. Are there any questions so far? No. Do you have any special interests? Anything that I should kind of detail? No? Good.
So I guess you're going to tell what's the source for the code, right? Like you also have some kind of JSON file, like the project, or you use the same basically?
Actually, sure. So what's the question is, what's the input for that entire system? How does it know what to do, right? And that's a real good question because that's all what matters, structured input data. So there are two kinds of input data. First, we have these JSON files that are actually pulled from Google because Google has a so-called discovery API which spits out exactly these JSON files. So that's how the Go implementation does it. So here you get this JSON schema, and that's exactly what you've seen everywhere. And the second part, obviously, is some meta information because I have to instruct my own build system how to generally deal with certain kinds of data. And yeah, I might want to open the configuration folder. So in etc of this project, I unfortunately can't make this bigger, but I can make it like so, if necessary. So here you basically have all the information for configuration. So first of all the JSON files that I've downloaded. And while I've written a little, well, there's a little make target that will download these files for me. And then there's the second part, the YAML files, right? Shared, and then we have some YAML or some configuration for the APIs that we generate. And I also generate command line interfaces for these APIs because I want to use this on the command line after all. So each of these have their own particular specialized YAML file. So the way this works is that when calling Mako, what we want to generate is a big data structure that contains information about the API that we want to build, along with metadata that I attach to that API, or that I attach to the surroundings, so that my tools know a bit more about what they're supposed to do. And the way this works is basically by just saying, okay, let's have a look at this, by the way. Let's see how this works. So let's have a look at an actual invocation. When we want to generate an API, for instance, let's see what kind of invocation we get on the command line. I think that will show how it works, and then it will explain in detail, right? First of all, to do that, I think I want to, here's the Mako invocation. I think I want to just show this instead of hiding it, so that we can have a look and just make the discovery one API. So that's a target I know exists. And as you can see, the discovery service itself, the one I've just shown, okay, not that one. The one I've just shown also has a JSON description for itself. Okay, that's not a valid target. Oh yeah, it's not just called discovery one, sorry. And it didn't do anything because, yeah, maybe I want to clean this. And now it should have to generate it. Okay. Yeah, it's a bit difficult to read, but what happens is that here, well, it's actually not that difficult to read. Sorry for that. Here we have data files that I specify. And as you can see, I tell it, okay, read this JSON file and read this shared YAML file, and then on top of that, read the data file that is just for APIs. And just to show you what this means is, if I create the command line interface for this, it looks pretty similar, but it reads a different specialized YAML file, which allows me to configure how command line interfaces should be. Because the system itself, it doesn't know that it's building CLIs now. It knows that it builds binaries now, because I have to instruct the Rust build system not to produce a library, but to produce a binary that in turn is depending on certain other libraries that I may also specify. So let's have a look at how such a file looks like, right? Because all that talking about the dependencies doesn't help a lot. So that's the shared YAML file, and if you want to build API, that comes on top. So just for you to understand, I think I didn't make that clear at all. These files are not just read and are kind of overriding each other, they're merged together, right? So I can, in fact, override values if I want to, but I don't have to. And usually, or well, in fact, all these files are merged into one big tree. It's really like a normal merge operation that is going on there. It's like it's cascading. It's like cascading style sheets. The same thing, but with arbitrary structured input. Inside of Python, it's just a dict, and you just merge dicts together. It's really that simple. And this is how it looks like. You know, all the structured data here is the stuff I made up. It's just stuff I need in order to know what's going on. For instance, copyright information, right? I want to bring this into I want to control this in a centralized fashion, so that's how I do it. If there are more authors at some point, I can easily add this here, and it will be updated in all the places that matter. So that's how the entire project works. If you want to change metadata, if you want to change anything really, you have to update something here. There are no magic values within the code itself. If there would be a magic value, I put it into the configuration, because otherwise you will at some point be doomed, and I don't want to be doomed. That's the specialized information that comes on top of the shared information. And as you can see, the key API here, for instance, it's listed in both files. But they don't override each other, but instead the stuff is merged. So basically, in the end, you have a data structure that has the keys API blacklist, API terms, API base path, API properties. It's all in one big tree. And this big data tree, well, basically just structured data, a dict of dicts, of lists, and whatnot, is then made available to the Mako template engine, which can use that in any way it wants. And that's just the first part. Now, we didn't generate anything yet, but we actually have the data, the information that we need to have a chance to generate anything. This is how that works. I can show you the Mako template engine. Sure, this is a library that I install with Virtua environment or with Python Virtua env. But the Mako render file here, the Mako render file here is the binary that is then using the library to do stuff. And I've modified this a bit because the default one can't do certain things that I needed to do. Part of that is, for instance, the merging. And here is the gorgeous merge algorithm that I blatantly copied from somewhere here, because it's all standard. As long as you know what you want, you don't actually have to write code anymore. You just have to know where to copy it from in a way. But if you copy code, be sure you respect licenses and be sure you mention where you got it from, or credit people. I try to do that, even though sometimes I might miss a point here and there. But that's my general attitude towards that. It saved me a lot of time. So this is that. And at the end of the day, I'm really guiding you through here real quick, but I don't need you to understand like each line. I'm just trying to pinpoint some piece of information that might be interesting. So here we've got the data files. We loaded. This also merges them together. And then what's interesting is this one here, this line. Because this line is basically the template engine of Mako that says, okay, actually this line is it. This line is the template engine, and you tell it, okay, render the output file. And this data that I have here is the entire data tree that we've been talking about for so long. And yeah, another cool feature is that there is a post-processing support, and which makes the system even more powerful. But we might get to that in more greater detail or not. So I think the next logical step would be to have a look at what it generates, right? Because right now I've just called this and something happened, but what's the result of the operation actually? So right now we've built the discovery API, and it drops everything into the respective folder under subdirectory under gen. And here we have the library, and the command line interface is basically in the same level of hierarchy. And this here is a standard Rust project, right? Unfortunately, I couldn't give an introduction to the Rust toolchain, but Cargo is the tool that will call the Rust compiler. It knows about projects and will basically be what you use to build anything. It handles dependencies. It allows you to run your unit tests. It allows you to run benchmarks and so on. It's really, Cargo is the thing you use all the time if you deal with anything related to Rust. Then, of course, you need a license file, right? This is a real project, and without a license file, nothing works. You need a README file. And this is all it has, like 50 kilobytes of code, or 50 kilobytes of a library file and some common code, which I just copy. So that's a differentiation. It's cool that you can generate everything, But sometimes, I mean, generating code is also, it's kind of meta, so it's something that you have to do, and it's cool to do that, but if you don't have to do that, then you don't do it. So in whatever I do here, there is a common file that I write myself, which I write by hand. And here I write everything that I can reuse throughout the generated code, which is good because, well, it's not really code reuse because it's not loaded in as a library or something, but it's at least from a maintenance standpoint easier to maintain than the generated code or than the generator code itself. So for instance here, the standard error type for the API, that's something I just have in my common code base. And certain implementations for that just make no sense to generate similarly all the time. And the other big part is the library, right? Here we go. And we'll just drop it in to show you what it generates. Okay, do not edit warnings, sure, the standard stuff. Lots of documentation here, because documentation is important. Documentation is a first-class citizen in any of my projects, because I develop open source stuff, and without good documentation, you basically have no chance of anybody even showing the slightest of interests. And it's also the first impression, basically. If you have a good landing page, then people might actually look at your stuff. So this is how the project presents itself. That's the main page for the basically main project. But if you look at one of the APIs, let's have a look at the discovery API that we've just seen. If you have a look at the README file, then you see, okay, it's markdown, it's nicely structured, it has links to other resources, it shows you how to use it, like an example, and basically guides you through everything you ever wanted to know about this project at a first glance. And if you want to dive in, you can do so. For instance here, that's nice. Let's see if any of these links actually works. No, it doesn't. Okay, I broke it. Regression testing, failure. But where you would get to basically is this page. That is the API documentation of the entire project. So that's a typical Rust documentation page. The Rust toolchain provides you with tools to build beautiful documentation that is cross-linked and has all the information you ever wanted. So if I wanted to search for, I want to do something with videos, then you might actually, sorry, I'm in discovery here. Sorry, I will not find anything with videos here. But if I am in YouTube, I might be able to just iterate through that and look for videos and find them. YouTube videos, and then dig myself down and actually find a way to maybe list my videos. Oh, look. And that's how that works. So you have examples for everything. These examples are unit tested. So the code here actually works. It's guaranteed to compile because I do compile it and I do run it. It doesn't actually do anything useful, but I definitely know it works. So that's also part of the Rust toolchain doc testing, which is very valuable, especially if you're able to generate all this bulk, basically. It would be bulk if you had to write it yourself, but if you can generate it, it's something that is very valuable because it allows people to easily understand how this stuff works. That is the documentation that I built so far, and it's really important to me to have this done properly. Back to the file. So that's all the documentation that you've just seen rendered as markdown, and that's really the smallest API there is because it just has two functions, some stuff. It's not much, like slug count probably of 800 lines, and most of that is documentation because really there is not much to it. It's nice to see that it expands to something that has 1,200 lines of something, but what's behind that? How does the macro generator code look like? Is this thing still maintainable? Is it possible to understand how this is actually generated? So how does that look like? So this is now kind of macro specific, right? Any generator would be different there. And my convention, and I think it is convention in general, is to name the source of some output like the output, but append a.macro to it. So that's how I basically structure my macro code. I shall also show you, maybe in another window, where this lives. It lives in source macro. And here's where all the templates live in. So that's the file we are currently looking at. And if you look at it here, just to give you the connection between these two, here we basically have a mapping of input to output files. So at some point here, I'm still trying to find it. Okay, that's a CLI. Here's a library. Here we have a mapping from the source macro API librs.macro to the desired output file, which lives at this path here. This is the file we've just opened. So this is how the system works, right? There is a from to mapping that I specify in the command line, which in turn, the information about that comes from the shared YAML files that you have seen. So I don't hardcode this anywhere in the make files. It's just structured data that I put into a list in my YAML file, and that's how that goes. Really easy to maintain. So back to the source of that librs that we have seen here. This is how macro looks like. So macro originally was made with HTML in mind, and this is why you have some sort of HTML-y syntax, which doesn't really matter to me. Fortunately, Sublime Text has syntax highlighting for this, because otherwise you're totally lost, because the librs really is super simple. So what you can see here is two important things. First of all, the macro generator code is structured as well, because you basically outsource all the complexity into their own submodules, which is super important, because generated or not, the project is complex, and generating this code is not too easy. Therefore, you need to be sure that, like with every other project that involves code, that you will have to basically organize your code properly, right? The second thing you see here is that macro integrates super well with Python, because here I have a code block that allows me to write native Python. If you can write Python, you can write stuff here, and it does stuff for you, which is super useful for generating or for mining the data that you have to generate data structures that you can then more easily use for generating your actual code. And this is what I'm doing all the time. So here, for instance, new context, it takes all the major data from the JSON files that has been loaded, and mines it, rearranges it, connects it, so that I have a context that I can then use with even more structured data in a way. And then the actual template stuff happens. So whenever something is not kind of included in these brackets and in something that is obviously highlighted as macro code, then it is template code that goes directly into the file. So this is written, as you see it here, into the destination file. So if we look at the respective file, and just to scroll up again, skip the documentation part, and here, this is exactly the same thing, right? But it's prepared, you know, the documentation part here, you haven't seen this even, because here I just say, okay, from my library module, I would like to just invoke a function that generates these docs for me. And this single line now expands to 170 lines of Markdown documentation. This is really all the magic. So as in every other program, but on a meta level in a way, you structure your code and put it into modules, call individual functions to make code generation easier for you. And long story short, these 145 lines of generator code, they boil down to now 1,500 or 1,200 lines. Or if you have a look at the YouTube API, this one, then you see that in case of bigger APIs, you get easily 20,000 lines of code, 40,000 lines. Okay, lines, that's not slug count here, but you get the point. You know, these 140 lines of code in the generator world expand to massive 20 to 40,000 lines of proper Rust code. You know, this Rust code is not only proper, it's good. Why? Not because I wrote it or something, but because I could really focus on the details. Because if you get the detail right once, you get it right for everything. And that's really the beauty of code generation that totally matters in this project. Any questions so far? No questions. I hope I don't lose you. If I lose you, tell me. If it's too boring, tell me, because we don't have to, I don't want to stretch it too, you know, unnecessarily. That's the point. Okay. Good. I think it's a good idea to get further and have a look at the command line interface, because really that's the thing that allows you to use this. So if I make the CLI here, then this will only invoke the generator. But what you actually want to do is to build a command line program. And in the Rust world, cargo is what's used to invoke the compiler. Cargo is their tool for everything. So I have a make target here that allows me to pass any kinds of arguments to cargo. So for now, let's see if I can pass empty arguments. Yes. So it tells me what cargo can do for that particular project. So I wanna run this. Let's run this discovery command that we also generate. So now you see. Now you see that obviously cargo knows that the command line interface depends on the API. So this is compiled first, if necessary, obviously. And then it compiles the actual command line interface. And at some point, it should run it. Something you also see, Rust is not a fast compiler. Rust compile times are really high. And yeah, so compiling YouTube takes like 2.5 minutes on my machine in debug mode, and it takes a whopping 40 minutes in release mode. So it's really, Rust compilation is something you want to outsource to someone else, I guess, especially if you have 40,000 lines of code. So this is a big project in a way. Anyway, what comes out of this is this simple command here that you can just invoke like any other command line tool. And it's fully documented, it's self-documenting. And you know, this is just like half the truth. There's even better documentation that I should be able to bring up like this. So if I have, you know, if I invoke my doc target, then it generates documentation for the command that, you know, I didn't write this yet. But if you want to know about the get rest capabilities, then we have all the arguments that you see in the command line shown in great detail. You know, this is kind of boring because it really just is two simple kind of read-only methods here. But if you do the same thing for YouTube, it gets much more interesting. And code generation, once again, shows that it can provide great value, because now you can invest some time in making nice documentation that actually helps. So for instance, if you download this YouTube command line tool and want to learn about it, then you would bring up this documentation page here, and then it'd say, yeah, I want to do something with videos, and I want to insert them, which probably is something like upload. Okay, this goes away. If you host this online, then the index is automatically called. So I'm now hosting this like with the file protocol, which is not the same. And statically compiled documentation. Then you get something like this. And all of a sudden, if you want to upload a video, you have to build such a video structure. You know, it's a complex nested data structure that is easily done in an API. Like if you want to nest some dictionaries in Python, for instance, you can do this to provide information about how it's supposed to be called and what the description is. But doing this on the command line is kind of difficult. So what I do here is basically just show you the entire data structure in a structured YAML-like manner. And then I show you how you can call, or how you can set each individual member here on the command line, right? This is how this goes. I don't want to get into detail how this works because it might not be too interesting for you. I can just tell you that the entire structure you can set with minimal overhead using the command line. This is what you need in order to actually upload something onto YouTube. And it's all generated. What I find fascinating about it is that it doesn't cut any corner anywhere. Whatever you can do with the API, you can do with the command line tool. You know, there are some complex data types that I can indeed not set, but I can set all the main ones, which is like hash maps or vectors of something or lists or simple structured scalar values here. And you do this without typing too much, you know, because it has this notion of a cursor. So you can basically go up the hierarchy level, go down the hierarchy level, and that way navigate that nested data structure and do what you want. Any questions so far? No? Then what else could I? Well, I could actually could run this just once. I think I should have it compiled somewhere because compilation of this guy takes a little longer, as I said. So that's how that command looks like when you actually execute it on the command line. And yeah, that is that. Error handling. Error handling is to me a bit like self-documenting commands. So I want my make to tell me what it can do. If I obviously don't know what it can do, I want my commands to tell me what they can do if I have no clue. I want them to be self-documenting. I want to have detailed documentation somewhere, but if I mess up, if I, for instance, want to, let's pick something. Let's try to do a videos insert, and then it needs a -r, and I have no clue. You know, this is what you read here then, like -r, what can you set? But I have no clue, so it's -r foo. And what else is there? Then we have to specify, you know, that's an upload thing. So we can have to set up the upload. So I want to have a simple upload, and I messed this up, obviously. And then I want to set a file, which doesn't exist, and it's a text file. And the MIME type is don't know, because I really have no clue. And then there are some optional parameters that I don't even want to set because they're optional, right? So let's see what that does. And that says that I was missing something else because that's the that's the argument parser that I didn't write myself. I use a library for this, and this will basically just say error, something was wrong, and drop you into this list. So that's not really the quality that I desire, but I think I must have made some obvious mistake somewhere. Oh, no, actually not O. Oh, yeah, true. Yeah, right. Sorry, this is parsed by the documentation parser. I should know that. So he realized that this doesn't exist or it isn't valid. And unfortunately, it doesn't tell me that. You know, this not the quality I desire, because it should tell you, listen, it's not simple, blah, blah, but simple or resumable. Please try again. But this doesn't exist now because that's really the first version of it, and there's much more work to do. So now it should actually give me something. And now where I'm getting at is I want my tools to tell me exactly what's wrong and not one after another, but you know, like a compiler does it. It should tell you everything that's wrong and then abort. So most command line tools, they kind of have an error and then they abort right away. But I would like my tools to actually find everything that doesn't work and tell you all at once. So foo does not match the pattern key value. Let's fix this. So now it's foo equals bar, so that should be fine. Then it's, what else? Field, foo does not exist. Okay, good. So that shows me that I can't go ahead with that. So let's set this one here. I'm just playing around with that to show how important good error messages are. So now I'm setting age rating alcohol content, and it's definitely with alcohol. And then we have these, and what else? Input, fail to open doesn't exist for reading with error. No such file directory, OS error 2. That's the second thing, which is really easy to do in Rust, by the way. Do not hide errors that happen somewhere else. So obviously this file could not be read, but what's the actual issue? If you have ever been debugging like tools for DevOps, then they say error, couldn't do stuff. I think you've had a nice slide that tells that, and I hate it. And I don't want to, it's about degenerating information here. And degenerating information is never good because you lose information, right? And this loss of information digests down to 1,000 users that waste their time, which boils down to thousands and 10,000s of euros spent. And do you want to do that? No. I just want to invest like extra 5 minutes to make sure that all the errors are handled correctly and in a nested fashion. Good, so that doesn't work. Let's give it the README file for uploading. And the last thing, done no is not a known MIME type. So application octet stream might be a better one. So let's try this. Oh, that's cool. I'm a bit curious, you know, I have to love myself because I didn't expect this to work now. So what it wants me to, it never worked. I'm not there yet, you know, it's okay, it shouldn't actually. So yeah, usually it would pop open the browser. I would just follow along and then conclude my demo because we're at the end anyway. And now you basically can log in here and enter the code. And there are better ways to do this. This is just the most primitive flow that I implemented. And there are better authorization flows that pop open the browser for you and kind of take away some of this work. Now you can go in here and it wants to obviously have read-write access to my YouTube account. And I think I want to grant that. And now it's authorized. And thank God. So now I've got the authorization. And I've got an error response that says not found, you know, and this is the part I'm working on right now because I generated the API or the service bindings, but I could never really test it against actual Google servers telling me if they like my stuff or not, you know. So I'm kind of I was doing this in the blind, and I'm using these command line tools now to at some point debug this. And again, as you can see, I don't degenerate information. I don't just say error. I say, hey, I couldn't do it. And the response was this. This is kind of debuggy right now. And obviously, at some point, you might want to have this in a nicer fashion. And, you know, but it's definitely all of the information that you will need to figure out what might be wrong. And, yeah, more to come. In theory, and I'm going to do this one more time, it should have stored the access token that it just received for OAuth 2 and just reuse it the next time it tries to do it. So it shouldn't be asked again, see? And that's another cool thing. It's all kind of, you know, it's all kind of built in already, and yeah. Anyway, I actually like to end this presentation of the project. Thanks for your patience because I know it's lots of stuff to digest. I still hope it's kind of interesting because there are lots of different tools that come together that are orchestrated with standard open source tools in order to tackle a very, very complex topic. We are generating actually nearly 1 million lines of code here that are guaranteed to be perfect, and all I have to do is run some make commands. I never run anything manually, which means it's reproducible. It's also unit tested. I mean, Travis is running on this, and when Rust comes out on the 15th of May this year, I will definitely release and deploy the first version of these command line tools, which will be usable by everybody. So at least then I recommend you to have a look at this again if you are interested to automate your own Google workflows. Maybe send some generated emails to people you hate or love and spam them. I don't know, you know, be creative. The tools will be there soon to do that. So thanks for your time.